Hello everybody! I hope everyone's having a wonderful day. So today we're going to be proving another property of big O. So namely that constants independent of the input to the complexity function do not matter. So in mathematical terms, what I'm saying is if I give you some real constant that's positive called k, and I know that f is big O of g given two complexity functions f and g, then I know that I get for free k times f of n. So if I take k and I multiply it by f, then it's going to be big O of g. Okay, so what we're going to do is we're going to prove that the constant, if we have a multiplicative constant in front of our function, or just multiplied to the original function, and we know that f is big O of g, then we're going to be able to get that for free. That's going to be the game plan. Because if that's true, and I show that it follows that this is true, then we're done. So think of these as givens that I can use. So it's an if-then statement. So let's try proving this. Well, you're going to notice very quickly, I'm going to try to use this property right here. And I'm just going to expand out that definition. And you're going to see how I'm going to use the definition of big O to prove a meta statement. So this statement about this new form of a new function in relation to g. So it's going to be kind of meta if you think about it. So I'm going to use a definition of big O. I'm going to invoke that to get properties, just like I've done previous to this. And I'm just going to proceed in that fashion. So I'm going to just show you how I do this. So as f is big O of g by the definition of big O, there exists, what exists if I know f is big O of g? What do I know? Well, I know there exists two constants, right? I'm going to call it c prime. There exists c prime, which is a positive real number constant, and n prime, which is going to be a positive integer, where f of n is less than or equal to c prime times g of n for all n greater or equal to n prime. You'll see why I'm going to use n0 and c for my actual statement I'm going to try proving. It just makes things a little more clerically easy to discern what exactly I'm doing. So I'm just using the definition of big O from this fact. So remember, I have those two facts I can play around with. I'm going to invoke the second fact here to know that I have these two constants I can play around with. We've done this before. So what I'm going to do, write down the game plan, right? We find constants. We find constants c, which is a positive real number, and n0, which is a positive integer, so that for all n greater or equal to n0, what are we trying to prove? We're trying to prove this right here, right? This is our goal. We want to try proving this given this information. So I'm going to write k times f of n is less than or equal to c times g of n. Remember, I can't assume what f and g look like. The only thing I know is that f is big O of g, which is why I invoke this definition. Now, you don't necessarily have to do it at the beginning here. You'll see why I'm going to do this in one moment. You could easily have written this sentence first. It doesn't matter too much. Some people will be like, oh, put this first. It's not a big issue. I'm just trying to show you that you could write this down a few different ways. So, now this is where I'm going to use this fact. Watch this. As k is a positive real number, pick c is equal to k times c prime. So remember, k is just some number, and it's not related at all to n. That's what it means to be independent of the input. So I could treat it like a constant. So I have k, and c prime is another constant. So I'm just going to multiply these two constants together. And that's going to be my constant c. So I'm going to pick c in this fashion. Then we find n0 such that k times f of n is less than or equal to c times g of n, which of course this is going to be equal to k times c prime times g of n. Now, there's a very important thing you need to be aware of, is that, remember, k is a positive real number, so I can treat it like a positive number. That means I can do certain algebraic things that I couldn't do if I knew k was 0. So I'm going to use that fact again. Well, k is positive, so by dividing both sides of the inequality, you get the following. You get k times f of n is less than or equal to k times c prime times g of n, if and only if, because I'm just going to notice that k is on both sides of this inequality. So all I do is this. So I divide both sides of this inequality by k, and now I end up with f of n is less than or equal to c prime times g of n. But what does that mean? What does that mean? Do you notice something that's very interesting about what I just did here? This little slick trick I did here. So notice I got rid of k here. Now look at this. I have f of n is less than or equal to c prime times g of n. Well, what is that? It's up here, right? I already know this fact. This is true already. I've presumed it as true, because f is big O of g. So what does that mean? Well, it means that that inequality has to hold, which holds for all n greater or equal to n prime. So what should we choose as n0? You're going to choose the n prime. And we're done, right? Therefore, by the definition of big O, sorry, my writing is sort of melting in the microwave. By the definition of big O, k times f is big O of g. And we're done. Boom. Piece of cake, right? So all I did was I just used the fact that we know f is big O of g, and this fact that I know that k is a positive real constant. So remember, it's a constant because this is independent of n. So you notice that k has no relationship with n. That's what n-dependent means. So whenever you encounter constants like this, they may as well just not even matter. That's the big takeaway from this proof that I just showed you. Where did it go away? Well, notice that all I really did is I used the fact I had originally from f is big O of g, and I just multiplied it by the k here, and it ends up dropping all the way through my proof. And you could say this about any two complexity functions assuming f is big O of g. So that being said, I want to say thank you very much, and have yourself a beautiful day. I'll see you later.